Hey everyone, today we're going to talk about interval and set notation. Interval and set notation are a little more formal way to represent points and intervals on a number line and eventually on both the x and the y-axis. While these may seem a little scary at first because they're different from what you're used to, I think you will soon find these a really efficient and really elegant way to represent where things lie on any graph. Before you watch the rest of this video, it would be really helpful for you to pause the video for a moment, and in the middle column where it says graph all of the equations and inequalities on a number line. This is something you're used to doing from Algebra 1. And it will really help connect the equations and inequalities in their symbolic form to the number line graph and then eventually into our set or interval notation. So pause the video and graph the equations or inequalities right now. Now that you've graphed these, if you would like to take a look and check them, make sure you compare what you did and make sure you make note of any mistakes that you made. Making mistakes are awesome. Making mistakes is awesome. Every time you make a mistake, your brain grows a little bit more and you get a little bit better at math. So think about what can you learn from the mistakes that you made and how can that help you understand math better and not make the same mistakes in the future. If you have any questions about your mistakes, make sure that you ask them either in the comments or through Canvas or ask me in class. Notice for these number line graphs, for a couple of them, I changed the inequality around so that it was Notice that for some of the graphs, I changed the inequality around in order to read the inequality from the variable. If we read the inequality at the top, starting with the variable, it would be x is less than -1, and then it's a little easier for us to draw our number line graph if we put the x on the left-hand side. Therefore, the inequality symbol. Motherfucker. Now that you've graphed these, I'll give you the opportunity to check them. Make sure you take note of any mistakes that you made. And again, remember, making mistakes is awesome. Every time you make a mistake, your brain grows a little bit and you get a little bit better at math. So right now, reflect on any mistakes you made. Think especially about open versus closed circles. Think about which way the arrow is pointing. Think about, are the dots connected or are the dots disconnected? All of these things are very important as far as communicating where things lie on the graph and are often mixed up by students. So take a moment to check your work and then make a note of any mistakes that you made and what you learned from them to do better for next time. Notice here, in order to make it a little easier to make the graph and to make the inequality symbol match up with the direction that's being shaded, notice that in the first one, I read the inequality from the variable. So when I read it from the variable, it reads x is less than -1. and then I rewrote the inequality that way with the x on the left-hand side to make the symbolic inequality look more like the graph of it. Notice that I did the same thing, ordering it so that 1 was before 6, which if we're reading left to right on the number line is the order that those are supposed to go in. Now that we've drawn the graphs, we need to get some important conventions of interval notation out right here. This is very important because communicating consistently in mathematics prevents people from getting confused. The rules for interval notation, we always read it left to right. We use squiggly braces. So that we have consistent language and that we can understand each other and not get confused. These are some of the rules that we use for interval notation. Interval notation is read left to right. We use squiggly braces for disconnected points. We use closed or square brackets when the endpoint is included, or in other words, when you would color in the endpoint. So that's used with the less than or equal to and the is greater than or equal to signs. And then open or round brackets are used when the endpoint is not included, where you would draw an open circle. And this is used for the is less than and is greater than signs. On our number line that we've drawn, one thing that we haven't really worked with before is what happens when it extends infinitely. For the arrows that show that it extends infinitely, going in the negative direction, we start the interval at negative infinity, and going in the positive direction, we end the interval at positive infinity. Since it's impossible to actually reach infinity, an open bracket will always be used whenever infinity is in the interval. When positive or negative infinity is used as an endpoint, an open bracket is always used next to it because you can never actually reach infinity. Therefore, it's impossible to include infinity as an endpoint. Now we're going to show how to formally represent the different points and intervals on the number line. First one, x equals 9. Because it's a disconnected point, we're going to use a squiggly brace. And since 9 is in the interval, we will use 9. And we represent it that way. Go ahead, pause the video, see if you can represent the next one. Notice the next interval uses squiggly braces, and since there's 3 points, the numbers 1, 2, and 3 are written in a list. Now we're going to do some where we actually have an interval that's shaded in. The first one, x is greater than 7. We need to ask ourselves, what number begins the interval, or what is on the left side? Because the interval begins at 7, we're going to first write 7, and the arrow on the right-hand side indicates that the interval never ends, or it ends at infinity, so we're going to use infinity. Once we've listed the endpoints, now we just need to decide what kind of bracket to use. Since 7 has an open circle, we will use an open or round bracket. And since infinity can never ever be reached, we also use the round bracket for the infinity. Go ahead and try the next 2. Once again, notice we started by writing the endpoints and then just decide which brackets to use. So round for the negative infinity, closed for or square for the 5, because the closed colored in circle means the endpoint is included. Negative infinity to positive infinity needs 2 round brackets because of the infinity. This is one of the most important interval notations to remember. Negative infinity to infinity means that all real numbers are included. Many functions that we're going to study have a domain of all real numbers. Once again, pause the video and see if you can represent the ones on the back. Once again, notice I began with the endpoints of the intervals, and so now based on whether the endpoint is or is not included, I'm just going to fill in appropriately whether I should use an open round bracket or a closed square bracket. Finally, the last one is a little tricky. Sometimes graphs break up in the middle of them, and we need to use multiple intervals in order to describe where things lie on the graph. For this, we have a special symbol. We use a U, which means union, and is used for representing or inequalities. For or inequalities, all we do is represent whatever intervals are there and then join them together in the middle with the U. So go ahead, pause the video and try that. So notice the first interval began at -3, Notice that the first interval began at negative infinity and then ended at -3, and then I used the open brackets to show the endpoints were not included. Then I put the union, and the second interval began at 1 and ended at positive infinity, and I used the closed bracket because of the inclusion of 1 as the endpoint. That's how you do interval notation. Make sure that you ask any questions, and make sure you try practicing some of these on your own so that you can make sure that you understand it and can communicate correctly where things are on the graph.